Hi guys, hope all of us are doing great. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. So today we're going to look at an aspect of the spherical coordinate system, and that basically is going to be the concept of base vectors. Now from our earlier discussion, the concept of unity vectors, we had said that we can be able to illustrate the concept of a unity vector from the Cartesian coordinate system of x, y, and z by having an extension from the origin of a vector which is going to be a unit vector in this specific direction for x, y, and z, and those are going to be aligned along this axis for x, y, and z. So therefore we can be able to define these specific vectors, space vectors, in terms of our unity vectors which lie along this axis and or rather parallel to this specific axis. Now with regard to that, of course, we can be able to transfer this specific information and also try to give a reference for those specific unit vectors in terms of a spherical coordinate system. And that is going to assist us, of course, to try to define the concept of base vectors in the spherical coordinate system. Now we are going to assign these base vectors in terms of a letter A. And in that particular sense, of course, we're going to look at the interaction of those three services that make up the spherical coordinate system and try to give the base vectors. So we had said that we can be able to denote a point in the spherical coordinate systems using the element for the radius, and then we had theta, and then we had phi, whereby we say that r is going to represent a radius from this point of origin to a surface of that specific sphere, and theta is going to be the angle that is going to be subtended by that right cone that we had given in our first case for the definition of a spherical coordinate system, and this is going to form a half angle that is going to have a range between 0 and pi, which is 180 degrees. So it's going to form the second element, and phi is going to be the extension of an the angle which is extension from the z-x axis to this particular point of the constant phi and the constant r and theta, as we have said. So the interaction between those three surfaces are going to form point P, and therefore we can be able to define these three unity vectors in the r, theta, and phi directions using these specific notations for a, r, a, theta, and a, phi respectively. So these are going to be unity vectors given as such, whereby we're going to see that these unit vectors are going to be mutually perpendicular to one another, whereby this specific point of interaction that we have mentioned, then therefore they are going to form a range of or rather set of those vectors which are going to be given as such, whereby we're going to have a phi, and then we're going to have the second one as we can have this one as ar, and then a theta respectively. So trying to feature or rather just trying to interpret these specific points at this particular point of P, then therefore we're going to see that there's going to be specific orientations which are going to be assumed at that particular point of P. And I'm going to use this, let me just use a different and try to see whether it's going to be more legible. So suppose we have this specific point, then we're going to see that the concept of phi for this last bit is going to be aligned along the, so the point of the extension of this specific angle is going to lie along this particular point in that specific direction. So that's going to give us a unit vector of a phi given as such, and then we're going to have the radius aligned along this specific direction. So therefore we're going to have this a r aligned. So it's going to be a projection or rather an extension of acceleration over this specific point for r that is going to be radially outwards from the surface of the sphere as we have just illustrated. And lastly, we're going to have what we call theta, which is going to be an extension. Of course, I can be able to just give it as such. So it's going to project to out of the board towards the in my indication. So I'm just going to give it this specific point, but it's going to be oriented along this line that I've given. So it's going to be a theta given as such, which are going to be mutually perpendicular to one another mentioned in that specific case. So the unit vector, if in trying to interpret this, the unit vector AR is going to be directed from the center of the sphere. And as I said, it's going to be radial and it's going to be normal to the surface of this specific sphere I've mentioned. So this is going to form a part of the right cone that I mentioned. which is going to form an half angle. Therefore, it's going to be a constant. Theta is going to be a constant, and the plane of phi as I've measured here is going to be a set of also a combination of those two, which are going to be constants respectively. So for a theta is going to be, of course, tangential. We can be able to sign this as a theta. So this is going to be tangential to the sphere. Tangential means that if this is the surface of the sphere, the tangent to this surface is going to be just passing through that sphere, as we have been mentioning for the definition of tangent. So it's going to be tangential to the surface of the sphere, and this is going to be a vector, the element of that specific vector a theta is going to be tangential to the surface of the sphere. And of course, we're going to see that it's going to be towards the direction of this specific aspect of theta. So we can be able to just illustrate this one using the downward direction. If it's going to be tangential to the sphere, and this is the increasing direction of this specific element for theta, and therefore it's going to be oriented in that specific direction as I've indicated. So, and then we're going to have this specific element for a phi, and also it's going to be tangent to the sphere and also in the increasing direction of this specific element for phi as I've mentioned. So it's going to project on that specific surface. So it's suppose I have a sphere that is, of course, can be noted as such. So it's going to be tangential along that specific surface. So this is going to be more elaborate on a three-dimension aspect, but of course I hope we can be able to interpret it from that specific aspect. So this range of 3 points, which are going to be, of course, mutually perpendicular, these specific points are going to form a set of the base vectors, and these base vectors are going to be explained, of course, or rather be explained or can be able to be illustrated on the surface of the spherical coordinate system, as I've mentioned. So this is going to form what we refer to as a vector, of course, which is going to be a vector P as I've given. So generally, we can be able to illustrate a vector P using the three aspects of the unity vectors, whereby PR is going to form a radius, and then we're going to have the unity vector AR being illustrated with that, and then we are going to have a combination of that one with the aspect of pi. So whereby P pi and P phi are going to form a set of angles as we had mentioned. So this is going to be P phi, and A phi. This one and this one are going to be angles, whereas this one is going to be the radius, and therefore this is going to form a vector of P insofar as the concept of unit vectors are concerned in this specific respect. So therefore, these are going to give us the aspect of these angles in relation to these three planes, which are, or rather surfaces, which are interacting for the spherical coordinate system. So this is going to be more elaborate, of course, in its areas of applications that we're going to come across, and they're going to assist us, of course, trying to interpret various points on a spherical coordinate system. So catch us in our next video on another aspect of those base angles, and of course, which are going to assist us understand more. So check in our comment section, or rather our description boxes, for various links of similar videos, which are going to, of course, assist us and complement on the same. So that is it for now, guys. Bye. God bless.